clear? Okay. We're all here to learn about Hadoop. But why are we even here to learn about Hadoop? What makes it hot, or rather what makes it piping hot, as the current market says? What is the necessity for us to learn such a skill or learn such a framework? The roots come from big data. Now, what is big data? It's a new term. What's big data? Most of us have already heard of it many times. As the name suggests, data which is really huge for us to store, to manage, to cleanse, and to process. It's really huge, it's a menace. So that's basically big data. As the name suggests, it's big for us to store it and to process it, in simple terms. This is for a layman, and if you want me to explain it in a textbook example, textbook way, it is characterized by 3 V's. We call it 3 V's. The first V is volume. Second V is variety. Third V is velocity. First one is volume. Now, the volume of data that is being generated in the current world is huge, is mammoth. Let me start off with a few examples as to how and from where so much of data is being formed. A basic example we all know, or we all rather use every day, is Facebook. Let me tell you that Facebook hosts approximately 10 billion photos. Okay, only the photo storage takes about 1 petabyte. I'm talking only about the photos. You have likes, you have videos, then you have each one's profile, you have each one's likes and dislikes. So many things going around on Facebook, right? So this will account to say 20 petabytes. Now, 1 petabyte is equal to 1024 terabyte, which in turn is equal to 1024 gigabyte. Now, see, this is the conversion rate. So 1 petabyte is 1024 into 1024 gigabytes. So that's huge. And we're talking in the order of 20 petabytes each day that's being generated in Facebook. How do you store it? Yes, this is one major problem. How do you store 20 petabytes of data in a machine? You just cannot. In layman terms, for me, I'm running on a 1 terabyte hard disk. Anything exceeding 1 terabyte for me is big data because I just cannot store it. Now the only solution that's open to me is that I have to use multiple hard disks to store it, right? I can use my internal hard disk which is inside my laptop, and I can use an external hard disk, say another 1 terabyte. So 1.5 terabytes, if that's the incoming data, I can fit it both in both of my hard disks. But there's a problem. If all the 1.5 terabyte is one single file, then how do you store it? You need to have a mechanism for me to split it, right? I mean, just guess it. How do you store a file that's really huge, a single file? Maybe you can split it and store, maybe, right? Okay, fine. Somehow you have some algorithm based on which you have somehow split it and stored. Now the problem occurs when you try to read that file, or when you want to process that file. How do you join it? You have 2 splits, and how do you join that file? So it kind of gets confusing, right? And I'm talking about 2 hard disks here. Say I have 10 hard disks and the data incoming is so huge that I have to use all the 10 hard disks put together. Now, as the number of hard disks, as the number of hardware pieces grow, I have to connect each and every hardware piece in a network. As I keep increasing the number of hardware pieces and I keep joining them through a network, there is every chance of the network failing. And there's more trouble ahead. So this is the way it goes. I mean, you can just think of it, how complex it can be, how complex stuff can get. Okay, so this is the problem faced which big data poses. The first V stands for volume. So much of volume is being generated around. When you go to a shopping mall, all you can see is QR code scanners or barcode scanners. Now they produce a lot of logs behind, okay? Machine logs. When you start a server, when you stop a server, there is so much of logs being generated. And it's really impossible for us over a period of time to store each and every log. Most of us, what we do is we archive them and we throw it in some other, archived hard disk. Well, you can ask me that why do we even have to store all these things? RFID junk, RFID output, why should we even store all these things? You might ask. Let me answer that probably 5 minutes later, but let me tell you the sources which cause so much data. Every morning, you guys, we all, rather, not by you, even me, have a look at the weather report, right? So if Khaja Gafur is from, well, I'm really not sure where are you from, but let me assume somewhere in the States, right? You might be wanting to know the climate of Chicago, and I, being in Bangalore, want to know the climate of Bangalore, right? So how does this whole thing work? We send a satellite out of space, to space rather, and then the satellite kind of scans the whole of the globe. Okay, it scans the whole of the globe, not only for the climate, but also for the temperature, for the wind, and all of the details. And it sends us back to the receiving station, which is on Earth. It might be in one station, might be in Bangalore, the other station might be somewhere in the States. So what the satellite gives you is really huge. I mean, it gives you anything and everything. It gives you for the entire world. But what the news channel broadcasts to you is only for, say, the United States of America. It really does not bother about how the climate is in some deep down part of Africa, right? They do not tell you. But the satellite gives you that detail as well. Now you need to have a processing mechanism wherein you would be processing what you want. Okay? Somewhere the output of the satellite's data, it has everything, but you need to filter out what you want and what you have to show it to the viewers. Okay? Now this is a pain because whatever the satellite gives, it's basically a live stream. Okay? So it keeps on streaming the data, whatever it collects, to the reception channel, to the reception place in the Earth, on Earth. Okay? So things can really get confusing when you talk about huge volume of data. You need to store it, you need to process it. The bad thing about big data is that it's a menace. But the good thing about big data is that you have got the information. Just that you must know how to process it. I shall tell you an example. Have anyone heard of mail trust? Is anybody from Europe? Anybody from Europe, guys? Okay. No, I was telling, has anyone heard of mail trust? It's a single word. It's a single word. I'm just stressing it. Mail trust. No. Okay. It's an emailing chain. Okay. Just like how Google provides a service, Gmail, there's another firm which provides mail trust. Now, assume that I really don't know the facts, but I'm just making a story out of it. Assume that they were put up in, say, some part of France, say Paris. Okay, they were originated from Paris. Assume. Now, then they had opened this service called Mail Trust, which is an emailing service. It was an instant hit in Paris. Okay, and as the word grew by mouth, as the word spread by mouth or by paper on paper, most of the Europe started using Mail Trust. Okay, and at one point of time, they realized that their servers could no longer take the number of hits which it was facing at that current moment. So they had no other option other than to spread out. That is, to have a new server or a couple of servers installed, as in to take more hits. But they were confused. See, if they had to go ahead with the cost effectiveness, they could have added another server in the same place where they were already in Paris. But no, they did not do that. They gave more importance to user friendliness, user experience. And the user experience would be fast, would be good, only if you place a server near to where most of your users are. Right, guys? if most of my users are in the States, and if I have a server back in Bangalore or somewhere in India, it is really not going to make any sense, because the distances matter, and because of the distances, there is something called as latency which creeps in. Latency is the time it takes for your ping to receive by me and to transfer the ping back to you. So it does take time. So if I keep a server somewhere in the States itself, the communication will be faster, right? So they wanted to do this, and they wanted to know from where are most of their users concentrated, from which part of the world. So what they did, they had the information already. Every day they used to have logs. Whenever a user logins, they would automatically get the username and from the place of the login, which part of the world are they logging in from. They already had the information since long, since the inception of the company, but they did not know how to use it, because there is so much of data that's being created, it really becomes a menace to process it. So what they did was that they went ahead and installed Hadoop. Okay. In Hadoop, what they did was they successfully managed to store all the data that they've got. Any user who logs in, or whatever happens, whatever activity he does, we all know it gets logged somewhere, right? Just that we need to make the right use of it. Now, what these guys have done, they have figured out the location of each and every user, and then they've made a kind of analysis on top of it, saying that, okay, most of my users are from Finland, so it would be a logical move if I place the new server, which I've been wanting to, in Finland and not in any other part of the world. And trust me, after they've done this, the number of hits, the number of customer satisfaction that they've been ranked is very, very high. So this is just a simple example saying that you already have the data with you, just that you need to know how to process it, which most of us don't know. This is exactly where Hadoop steps in. It will help you to store data easily, and it will help you to process data even more easier. So this is the first V, volume. Now, the second V stands for variety. Now, if data can be segregated, classified, it can be done in three. It can be segregated into three types: structured data, unstructured data, and semi-structured data. Structured data, as we all know, any data that fits inside a table is structured data. Any data that you take off from RDBMS is structured because it is stored in cells, which is an intersection of a row and a column, right? So everything in RDBMS is structured. Now, unstructured. Can you give examples? Absolutely. I mean, when you do a select star from, I'm assuming most of us are familiar with RDBMS and SQL. If you do a select star from table name, all you get, whatever you get, is in structure, right? I mean, you have a column, you have a row. Am I right? And each and every cell has a particular schema, like say name has been given a schema, or I mean, the data type is string for name, and for age it is an integer or a double, and for sex it's again a name, string, and so on. So everything is structured. There is no concept of unstructured data here. Absolutely, absolutely, Srinivas. See, so it's all structured. I mean, whenever you find a beautiful table, keep your eyes closed and think of structured data, because it is structured data. Okay. Any data which fits inside a cell, which fits inside a beautiful table, is structured data because it adheres to that rules, right? Name cannot be, okay, age cannot be a string. That is what the data type definition says, because when you have a column called age, you have to define a data type associated with it. And basically, age, we will assign it either an int or a long or a double, right? So if you try to insert a name inside an age, it will throw an exception. So what is it we are doing here? We are trying to make a structured data unstructured, which it resists, right? So this is unstructured data for you. Simple, guys. Any data which fits inside a table is structured. Okay. Unstructured data. Take any text file. Write, hi guys, good morning, how are you doing? I'm learning Hadoop. Are you adhering to any structure here? Nothing. You're just jotting down whatever comes to your mind. This basically is unstructured. which does not have any schema, which does not have any definition, which does not have any rules, right? Guys, are you getting it? Yep. Any trouble still now? Yes, image files, video files. So all these things are basically unstructured. Okay, as Srinivas pointed out, image, videos, anything. I mean, everything is unstructured when it comes to a text file or any binary files. All are unstructured data. Now, what is semi-structured data? Semi-structured data is like a, sandwiched between a structured data and a unstructured data. Semi-structured data actually does not conform with a formal structure. Okay. Okay, let me put it in simple words. Tags. Any data which has tags to it makes it kind of semi-structured. I'll tell you an example. Most of us have seen blogs, or most of us would have at least tried creating blogs once in our lives, right? So when you try to create a blog and when you post it, like say this is my post. This is the heading, and I go on writing blah blah blah. Okay. Now at the end of this, just to receive more hits to my site, I have to define something called as tags. Right? Hadoop is my tag. Awesome. If I want hits of this kind, Hadoop, awesome, cool. So these are basically tags. Okay, so what does it make? I mean, you have a completely unstructured data on this side, the whole content is unstructured, but you are assigning some tags to it in a comma separated way, which makes it kind of structured. If this is structured and this is unstructured, the whole thing, we call it semi-structured. If most of us have not used blogs, then let me give you another example. What do you do in email? The same thing. You have a body of an email wherein you write whatever comes to your mind, and you have a subject. So subject is like adding a tag to it, right? So on seeing the subject itself, you at least will have an idea as to what the body of the email can be, right? So the whole of the body is completely unstructured data, but when you give it a subject, it kind of makes it a little bit of structured, making the whole thing semi-structured data. Am I clear, guys? Yep. Cool. So this is variety for you. In big data, it's all about variety, my friends. You cannot expect only structured data to come. Video, yes, sensor data, video files, audio files, image files, anything and everything. Text files, logs, okay? Logs is the major menace. I mean, they are really, really huge, and it has all the information. Why are logs used? If there's any error, if there's any real issue in the future, we go back to the logs for that particular day and we check it. So what does this mean? You've got the information, just that you must know how to use it. Assume that my application is so huge, I mean it is having so many hits that it is generating logs on a huge scale. Say every 10 log files in a minute. Okay, so that makes it in 1 hour 600 log files. So if I'm getting 600 log files in an hour, and 3 days later a particular user is complaining of something, then I have to go back to that day's log on whatever day he is complaining about and then check it. If I have so many logs, it really does make a problem, right? So this is where volume and variety comes into the picture. It poses a lot of trouble. The third one is velocity. The third V stands for velocity. Now, velocity is the speed at which your data is getting, generated. There are a couple of examples with which I can tell you that the data is generated in the current world at a rapid pace. Now, in the case of stock exchanges, right? Most of us do broking, right? Now, in the case of stock exchanges, well, let me tell you an example with NYSE, New York Stock Exchange. it generates about 1 terabyte of new trade data per day. 1 TB per day. I mean, 1 TB in the current standard might be less, but 1 TB per day is huge, right? At the end of 1 month, you will be ending up with 30 terabytes of data, right? So storing it, processing it really becomes a menace. How the log data is currently handled? They have some mechanism to pull the data. How is Hadoop any different in this scenario? Let me explain that to you, but let me first tell you what the 3 Ds are. Okay. Now, see, the problem in the current world is simple, guys. You have your incoming data, and you have your hardware on top of it, which would help you to store it and which would help you to process it. Okay. Now, there's incoming data, and I'm processing it. I'm storing it quickly and I'm processing it. Cool. Now, by the time I do this, if there's another load of data, incoming data, I have to do that as well. In which I have to finish the first task, only after that I can finish the second task. Right? So if the time interval of this and this is 1 hour, okay? So the first load of data comes, new loads of data comes every 1 hour, and the processing takes 2 hours. Okay, it is impossible for you to finish off storing and processing the data. Am I right? The processing time should be less than the time interval of the new load of data. If the processing time is more, you basically are getting inside a loop. That is, you are processing the data, and before you finish off the processing, there's another new load of data coming in. And before you finish processing that, there's another new load of data coming in. So this is the velocity of data, right? So the time interval between loads of data, the time difference between the creation of data. Log files can be created, say, every minute, every hour, every day. It can be anything and everything.